A ball is thrown upward from an initial height of 12 feet. Its height in feet, h of x, above the ground can be modeled by h of x equals negative 0.1 x squared plus 0.7 x plus 12, where x is the ball's horizontal distance in feet from where the ball was thrown. Part A. Find the ball's maximum height. Well, to answer this, it might be prudent to answer part B first. How far from where the ball was thrown does the maximum height occur? Let's find out where the maximum occurs, because the maximum of a quadratic is going to occur at its vertex. So let's go ahead and find its vertex first, or find the h value so that we can find k in our vertex. Let's see what we can get. How far from where the ball is thrown does the maximum height occur? Well, I'm going to say x equals, or actually let's say h equals negative b over 2a. Well, my a, b, and c, a is negative 0.1, b is 0.7, and c is 12. So this will be negative 0.7 divided by 2 times negative 0.1. And if we divide that, that would be negative 0.2 in the denominator. Negative 0.7 divided by negative 0.2 is 3.5. So how far from where the ball is thrown does the maximum height occur? 3.5 feet. Now the maximum height will occur at that point, so k equals f of h. In this case, the f is our function h of x, and h is the value we just found. So we'll find h of 3.5 equals negative 0.1 times 3.5 squared plus 0.7 times 3.5 plus 12. And I'm going to go ahead and do this with a calculator. 3.5 squared plus 0.7 times 3.5 plus 12. That is 13.225 feet, since that's what our units are. So both the height and the distance are given in feet. So 13.225 feet is what the maximum is. Now, our last part of this question says, how far does the ball travel horizontally before it hits the ground? Now, we have to think about this in context. When it hits the ground is the point where we hit the, quote, x-axis. In this case, the x-axis is the ground. We've got a ball flying through the air. That would be the x-axis. So let's take our function. I'm going to rewrite that. Negative 0.1 x squared plus 0.7x plus 12. And we want to solve where this is equal to 0. Let's see. We could attempt to factor this. I don't feel like that would be a great plan. So let's use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, well, negative b, that would be negative 0.7 plus or minus the square root of 0.7 squared minus 4 times negative 0.1 times c, which is 12, divided by 2 times negative 0.1. Now, I'm actually going to do this in the calculator. Negative 0.7. Actually, let's do the discriminant first. 0.7 squared minus 4 times negative 0.1 times 12. 5.29. So this is the square root. 5.29, negative 0.7, all divided by, and that would be negative 0.2. All right, negative 0.7 plus the square root of 5.29, and then divided by negative 0.2, Let's be negative 8. That's one value. I'll do the same thing but with a minus. Negative 0.7 minus the square root of 5.29, and then divided by negative 0.2 is 15. So which makes more sense in this context? We have negative 8 feet or 15 feet. Due to context, 15 feet is the value that makes the most sense. After having traveled 15 feet, it reaches the ground. All right, we have one more application problem. A 4th grade class decides to enclose a rectangular garden using the side of the school as one side of the rectangle. Before I get too much further, let's go ahead and draw this. We've got the school over here. What's the maximum area that the class can enclose with 32 feet of fence? What should the dimensions of the garden be in order to yield this area? Draw a diagram. Well, there's my diagram. Now I'm going to label my dimensions as, let's say, x and y, so that 32 feet of fence we have actually represents 2x plus y, because that's the distance around, and we're not measuring the side of the school. Okay, well, that's one thing we can pull from this. Well, we want to maximize area, though. I want to maximize area. Well, area equals, in this case, x times y. The length times the width of that box. What I'm going to do is take that equation that I just wrote, 2x plus y equals 32, and solve that for y. So that would be negative 2x plus 32. And then replace that value of y into our area formula. So area equals x times minus 2x plus 32. So that my area formula is minus 2x squared plus 32x. Now, to solve this, well, there's my function. If I want the maximum area, that would be actually finding the vertex in this context. So let's go in that direction. We have h equals negative b over 2a. But here, a equals minus 2, b equals 32, and c equals 0, because there is no constant term. So our h would be negative 32 divided by 2 times minus 2. That would be minus 4 as the denominator, so this is positive 8. 8 equals h, or h equals 8. But that is not the maximum area. That is what value of x gives us the maximum area. So that will be helpful. We want to know our dimensions. But we can find the next value, the actual maximum area, by finding k, which would be negative 2. Well, actually, let me write this here. That's f of h. So this would be negative 2 times 8 squared plus 32 times 8. So that k equals 8 squared 64, so that's minus 128, plus 32 times 8. This is 128. So that is where our area function is maximized. Now the dimensions, those are our x and y respectively. So we should have an 8 foot by 128 foot rectangular garden, okay, with a maximum area of, oh, actually scratch that. That 128 is our maximum area. Maximum area of 128 feet squared. To find our other dimension, we need to backtrack a bit and use this equation over here to find the y value. So y equals negative 2x. We're going to use this value here, 8 plus 32, and that would be negative 16, so that is 16. So we need an 8-foot by 16-foot garden to have a maximum area of 128 feet squared.